Hi, my name is Oscar Taracena and I will talk about the comparison of two papers, a Brazilian paper of 2018 and a Chinese paper of 2012. Both focus on the characterization of fatty acid methyl esters, known as FAMEs, in biodiesel by liquid chromatography. Biodiesel is a green alternative to fossil fuels and it is obtained by the reaction of used vegetable oils and alcohol. It is composed of several fatty esters, for example the methylolate, MO, methyl linolate, ML, and methyl palmitate, MP. There are standards in the US and Europe to characterize the composition of biodiesel using gas chromatography, but it is more time and reagent consuming. A comparative table is shown in the slide. Biodiesel from soybean oil was the sample of both papers and the analyte was methyl oleate, MO. The Brazilian paper focuses on comparing results with gas chromatography using UHPLC with UV detector at 205 nanometers, and the Chinese to create a mathematical model to separate peaks of MO and MP using an HPLC with refractive index detector and UV detector at 210 nanometers. Both methods use silica-based columns with same particle size, same diameter and length. They use identical flow rate, temperature of the column oven, as well as injection volume of the sample. The main difference is the use of two mobile phases, methanol and 2-propanol, with linear gradient elution in the Brazilian paper and only pure acetronitrile in an isocratic elution in the Chinese paper. The run times were 15 and 30 minutes respectively. As main results, we have the chromatograms of both papers. It is possible to see that in the soybean oil chromatogram of the Brazilian method, that the methyl oleate alone was near the 8th minute, while in the Chinese paper it was possible to be identified in the 12th minute with another peak. From the Brazilian paper, it was possible to compare the FAMES content with GC method and, statistically, using a deeper test with a confidence of 95%, there was no difference in the results. On the other hand, in the Chinese paper, it was possible to determine two equations from the RI and UV detector to separate MO and MP peaks. The main advantage of UHPLC with gradient elution is that the runtime and the identification of MO is faster than HPLC. However, requires a specific filtration and is more expensive. On the other hand, the Chinese method is cheaper and only requires one mobile phase, but it cannot separate the MP and MO peaks without previous mathematical equations. As a conclusion, the gradient elution in UHPLC improves the MO and MP peak separation, and liquid chromatography is a great alternative to gas chromatography in biodiesel analysis. Thank you.